One's 1.
Alright, what's sine of 30?
Which is
half.
Half. Okay, sine 45.
1 root 2.
Now, what is cos 45?
1 over root 2.
Same as sine 45, remembering your complementary angle result. What is cos of 60?
1 over 2.
Okay, complement of sine of 30. Okay, so you don't have to remember all of them necessarily if you remember your complementary angles work. Right, sine of 60.
Root 3 over 2.
Good. Therefore, cos of 30 is?
Root 3 over 2 as well.
Okay, so they're your supplement angle results. Okay? Means they're equal. Alright, because of what we proved in the previous lesson. Alright, tan of 30.
1 over 3 squared.
Not 3 squared? Root 3, yes. If it was 3 squared, we'll be writing 1 on 9. Okay? Alright, tan of 45. 1.
Yes! Got this.
And tan of 60 is root 3. Alright? So, you need to either derive it or remember it. Okay, this is a requirement. Now, or, you know, I had students when I taught them 2 years ago, they actually wrote them on their bathroom walls and stuck posters up on their doors. Okay, and they've actually remembered it. Alright, so that's something you might need to do. Alright, on the bottom of your skateboard. Okay,
that will be gone in like.
I'm going to do that.
And carve it out of the sandpaper bit.
The grip tape. I can do that.
Okay, so good. Right, so now we have 6.5. Right, we have trig metric equation. Okay, so last lesson we looked at example was sine of 600, for example. Sorry, sine of 300, for example, and we're asked to do the exact value of something other than what's in this table. Okay, so the way we did that is we used the properties in that table, right, and then set up an expression so that we could work out the value of our angle. Okay, so last lesson, and the video is up as of yesterday afternoon. Alright, so examples. Alright, eight of them, alright? A. So, tan of theta, which is equal to root 3. Right, so now we're using our equation skills to solve these expressions. Right, so we are solving for the angle theta. Right, so what's the value? 60. Is that the only solution?
No.
No, why not?
Because you can do the other stuff too.
Yeah, we have to do that other stuff as well. Alright? So, we have to consider all our quadrants, okay? Now, the question, example, it asks to solve the following equation in the domain 0, which is less than theta, which is less than 360 degrees. Right? So we need to find all those possible angles within that domain that will make this equation true. Alright? And we start with this table here. Alright? So, basic angle. Alright? So we're referencing, that's your reference point. Alright? So tan of 60, which is root 3. So the basic angle is 60 degrees. That is one of your solutions. Okay? To get any more, you need to consider the quadrants. All students take calculus. Alright? Tan of theta is equal to a positive root 3. Alright? So where is tan positive?
A.
Okay, first quadrant and the third quadrant. Okay? So 60 works because it's in the first quadrant. So theta is equal to 60 degrees. And what's a measure of the angle in the third quadrant? How do we calculate it?
180.
Good. Okay, so at this point we have 0, 90, 180, 270 degrees. Okay, remember this is different to your bearings. Bearings start differently at a different point and go the other way around. Right, so you're basically taking it from this axis here. Okay, so we always, in the second quadrant, we get 180 minus the basic angle. In the third quadrant, 180 plus that basic angle. And in the fourth quadrant, it's going to be 360. Take away that basic angle to get them in those quadrants, okay? So it's going to be 60 degrees, and an angle in the third quadrant is going to be 180 plus the basic angle, 60 degrees. Okay, so equals 60 degrees, 180 plus 60, so 10 of 240 will also equal root 3. Alright, and that's all our solution for that value. Right, B. So sine of theta, which is equal to -1. Right, everyone here has seen the sine curve. Familiar with what that looks like? Let's do a quick sketch underneath. Something like that. There's the period, 1 revolution. 360, so halfway down is 180. Alright, so we need to find the value, so the amplitude will be 1, so -1 and 1, that's where the amplitudes are. Alright, so that's what we're doing, we're finding the value for theta, that equals -1. So reading off my graph, where would that be?
90 and 270.
Say it again, sorry?
90 and 270.
Well, it's -1.
Ah, 270.
Okay, so at this point here, alright, so 270 degrees. So that's what we need to do for our answer. Go to that section. Alright, I haven't actually told you. No, we don't have the exact value of 1. We haven't done that section yet. Alright, so at 90, so the basic angles, the sine of 90 degrees will equal 1. Okay. That will be covered in a future lesson, I imagine. Alright, so the basic angle is going to be 90 degrees. Now when you consider the basic angle, you ignore the sine. Okay, so you treat it as positive, and you then consider the sine when you look at your quadrant. Okay, the basic angle is 90 degrees. So, all students take calculus, which quadrant is sine negative?
2.
Alright, and the second, so the third and the fourth. Alright, only tan and cos are positive. Alright, so theta is going to be an angle in the third quadrant, 180 plus the basic angle. And also equal in the fourth quadrant, 360 take away that basic angle. Alright. So, which will be 270 degrees. Okay, and really we only need to write that 1. Alright, graphically we identify where it is, and now working on our equation skills and considering the quadrant, we have that answer as we expected. Alright, any questions before I try the next couple? We all following what we're doing? Alright, let's look at C. Right, so 2 cos theta is equal to 1. Okay, so if you were solving this like a normal equation, you want to get theta by itself. Okay, so this is 2 times cos theta, which is equal to 1. Okay, so the first thing I need to do is divide both sides by 2 to move that 2 over. So cos theta is a half. Alright, if we were to solve for theta previously, we'd go theta equal cos inverse of a half. Alright, and we get 60 degrees. Alright, so that's not our only solution. So maybe back in the last couple of years, if you were to do this, because you're only familiar with the angle in between 0 and 90, because it's only right angled trig. Okay, so now we're actually extending that further. So the basic angle is equal to 60 degrees. Alright, so once you identify that point, this will be a 2-mark question. The first mark will come from the consideration of what the basic angle would be. The second mark comes in after you have considered and then told me what the values for theta would be. So the domain, remember, between 0 and 360, so we're only doing 1 revolution around the number plane. Right, so where is cos positive?
Cos A and C.
Okay, first and fourth quadrant is where cos is positive. So the next line, so theta is going to be the basic angle in the first quadrant, right? And it's going to be 360 take away 60 in the fourth quadrant. Alright, then underneath tidy that up, so 60 degrees and 300 degrees. Alright, so what this means, if I consider my cos curve, which is something like this, so that's 90, 180, 270, and this equation was 2 cos of theta which equals a half. So in other words, cos theta equals a half. So we're looking for the point, so this is 1 here, and this is minus 1. We're looking for the point on the graph where we're getting a half. Okay, so we consider a horizontal plane there. Alright, so just before 90, so there's the 60, and then after the 270, not long after it, so there's the 300. Okay, so that's what we're doing when we solve these equations. Okay, the alternate, yes, you can graph it and then read off your graph. However, when the equations start becoming a bit more difficult to graph those curves as well, it's not always the most practical solution, method of working them out. Right. D. Tan squared theta, which is 1 on 3. Okay, so remember, tan squared of theta is tan of theta all squared. Okay, so tan of whatever that angle is, and we square the whole result. Alright, the notation is we put the square before the theta. Alright, so what's my first step? Take the square root of both sides. Alright, so tan theta, which is going to be the square root of 1 over 3. What else do I need to consider? When I take the square root of a number, plus or minus, alright? So here we're going to have 4 possible solutions, so we need to investigate. Alright, so tan theta, which will be plus or minus, square root of 1, which is 1, and then the square root of 3. Can't simplify it any further. Right, tan of what angle in the first quadrant makes 1 on root 3? Okay, 30 degrees, that's our basic angle. Consider the positive of your result. Okay, then you do a number plane and consider your sign. So where is tan positive or negative?
All.
Everything. So that means we're going to have 4 possible solutions. Okay, in all 4 quadrants, tan is either positive or negative. Okay, so angle in the first quadrant is that basic angle. An angle in the second quadrant is 180 take away the basic angle. An angle in the third quadrant is 180 plus the basic angle. An angle in the fourth quadrant is 360 take away that basic angle. Okay, and that came from deriving those results. Right, so your first mark comes from identifying the basic angle by getting it into a state where you can state the basic angle, and then your second mark comes from stating all the possible solutions you can have, including it in the simplest form. 30 degrees, 150 degrees, 210 degrees, and 330 degrees. Alright, so if I had to sketch my tan, then I'll find plus or minus root 1 on root 3 up and down, so plus 1 on root 3 up, and then 1 on root 3 down, and then I've got 4 possible points between 0 and 360 that makes that equation true. Alright, question? Right, E. Cos of 2 theta, which is a half. Alright, something again slightly different. Right, so I've just got cos on the left hand side. Okay, cos of an angle on the left hand side. Alright, so I need to go the basic angle. So what cos of what angle equals a half? Cos of 60 gives you the basic angle. Okay, and then you go do a quick number plane sketch, label your 4 quadrants where your ratio is positive. So where is cos positive?
C and A.
Okay, in the first and the 4th quadrant, where cos is positive, sorry. So, all these previous examples, we had cos of theta, tan of theta, and likewise before. Now we have a cos of 2 theta. But that's my starting point, 2 theta equals. So we have 60 degrees, and basic angle is in the first quadrant, and then 360 take away the basic angle. Okay, so that equals 60 and 300. So would I be finished right there?
No, you got to get rid of that 2.
Okay, so we need to divide through everything by 2. Then you need theta of the subject. So theta is therefore going to be 30 degrees and 150 degrees. Alright, so if you had 3 theta, you have to divide by 3. If you had theta plus 30 degrees, you'll need to subtract 30 degrees of each of those angles. Okay, you need to have theta by itself by doing your normal equation skills. Right, and then we've got an example there, cos of 2 theta take away 30 degrees. Okay, which equals to root 3 on 2. Okay, so we've got cos of an angle, which equals root 3 on 2. Alright, so what is that basic angle that makes that equation true? Cos of 30 is root 3 on 2. That's our basic angle. Okay, so basic angle means an angle in the first quadrant. What angle between 0 and 90? We'll do that. And then you consider, by drawing this quick diagram, that you are showing your markers that you are considering your quadrant. So we have a positive value on the right hand side. So where is cos positive? Okay, so in the first and the 4th quadrant. Okay, so that means cos is positive in the 4th quadrant, everything else is negative. So, inside that bracket, 2 theta is equal, 2 theta take away 30 degrees is going to be 30 degrees, and also will be 360, because the angle in the 4th quadrant, take away 30 degrees. 30 degrees, 330 degrees. Alright, so I have 2 separate equations. So 2 theta take away 30 is equal to 30. Alright, we have 2 theta take away 30, which equals 330. So what's my next step?
Add 30, then divide by
Yep.
2.
Good. So we add 30 first. So it's going to be plus 30, plus 30, plus 30 to all those values. So that means 2 theta is going to be 60 degrees and 360 degrees. What's another way of writing 360? 0. Okay. Now, the question at the start specified this as the domain. So 0, which is less than or equal to theta, which is less than or equal to 360 degrees. So because of, yeah, it will work. Hang on. Yes, because if I set that also to 0, and then also have 2 theta, which is equal to 0 degree. So there's the third possible solution. Okay, because of course we can divide by 2. Hang on. Let's just finish this off first. So divide everything by 2. Yeah, it would be, yep. Right, so therefore theta, which is equal to 30 degree, which is equal to 180 degree, and also will equal 0 degrees. Because if I substitute 0 in here, so I'll get cos of negative 30, okay, which is the same as cos of 330. In the second quadrant, we will also have that root 3 on 2 value. Alright, so when you get the endpoint, because they're less than or equal to, alright, that means 0 will also be a possible solution. Alright, any questions on those before I do the last two? Is everyone somewhat following what's going on? Yep.
Yep.
Yep. Josh?
Yep.
Right, G. Right, so tan squared theta plus tan of theta take away 2, which is equal to 0. Exactly, that's why I stop every couple of questions I ask before I move on to the next one. Right, what does it look like? Looks like a quadratic, doesn't it? Alright, so to do this, so let x is equal to tan of theta, and we'll cover this in more detail when we do the quadratic function towards the end of your course. Okay, so if we let x equal tan theta, the expression becomes x squared plus x take away 2, which is equal to 0.
Oh,
Yep.
Yeah.
Okay, and now we can use our skills that we learnt in chapter 2, or chapter 3 actually, in equations, and you also learnt how to start it in chapter 2. So, two numbers multiplied to give negative 2, same two numbers add to give positive 1.
1.
You sure?
1 negative, no.
Multiply to give negative 2, add to give positive 1.
2 and 1.
X plus 2, x take away 1. 2 times negative 1 multiplied to give negative 2, you add those two values together and you get positive 1. Alright, so therefore x equals 2 and x equals 1. So, negative 2, x equals negative 2, and x also equal to 1. Alright, are we done?
Yep.
No, so what we have to do next? Good, so we set x equals tan theta. Alright, so therefore tan of theta, which is negative 2, and tan of theta, which is 1. Right, so sometimes you are not going to get this basic angle. Alright, there is no basic angle for tan of theta equals 2. Alright, so the basic angle, and you can do this the same to work out all your basic angles, is tan inverse of 2. Okay, so when we worked out the basic angle here, we do a cos inverse of root 3 over 2, and we will get 30 degrees. Alright, over here, the basic angle number 2, so tan of what equals 1? Tan of 45 degrees. Okay, in other words, we go shift tan 1, and we're going to get 45 degrees. Alright, so we know that basic angle. Alright, the first one, tan of theta with negative 2. So where is tan negative?
First and C. So second and fourth.
Second and fourth only. Alright, so theta, which is going to be 180 degrees, take away 10 inverse of 2. That's your basic angle. Okay, and in the fourth quadrant it is 360, take away 10 inverse of 2. Alright, so you want the exact values. You don't want to simplify because I had not asked you to specify degrees, minute or second rounding. Alright, so we have to leave it like that. Alright, that's the simplest that we can get it. Alright, so 10 of theta is equal to 1. Alright, so where is 10 positive?
All of them.
No, they
10 not positive in all of them.
What? What?
Kyle.
Ah, right.
Everything's positive, only sine is positive, only tan is positive, and only cos is positive.
0 has the plus. Oh.
Because we had both plus and minus solutions. You can see then. Alright, so theta is equal to 45 degrees, and we also have 180 plus 45 degrees. So 45 degrees and 225 degrees. Alright, now everyone with their calculators, let's make sure all those 4 solutions work. So, either store the variable, so you have to do this 4 times, okay, so you want tan of this value all squared, take plus tan of this, take away 2, and you should get 0.
So what?
Alright, maybe best everyone to do this first, hang on. Do we all know how to store something in your calculator?
I don't have my calculator.
Alright, can everyone please put this in? 180, take away 10 inverse of 2. Everyone should be able to put that in the calculator. Yep, push equals. And then shift. Then you push shift. And then above the
There's like
above
there's
the
a circle with a comma.
above the RCL, above the number 7. Okay, it's the button store. And then you have a whole list of variables on here, A, B, C, D, E, F. Alright, so pick one of those values. So you have A, B.
That's what they're for.
Yep.
Dude, that's cool.
I never knew that.
So you put it on A.
Yep.
Alright, let's do that. Everyone do it on A.
Okay.
Yep. And it should be stored.
Yep.
So then if you go alpha, and then you push A, and then you push equal, it'll come up with a decimal for that.
That's cool.
Alright,
I never knew that.
there you go, we learnt something
Yeah.
today.
That's something.
Yeah.
Right, this makes it easier because then now you can punch in this expression 10 of A, what you stored it as, and then brackets around it, square the whole thing. So we need to push in your calculator 10 of capital A in bracket all squared.
Oh, okay.
Okay, plus 10 of A, take away 2. Yep, so it needs brackets, 10 of A
Yep.
squared, plus 10 of A, take away 2. Push equals and you should get 0.
Yep.
Alright. Alright, so do this again. Store either as A again or store it as a different letter. Now you need the next one. 360 degree, take away 10. So call this A, call this B. So everyone store that expression in B and then do that quadratic again.
What? 360.
Okay, this function is very handy that you don't round your answers early. And then you can substitute another variable into an equation like this, what we're doing now. You got 0, Josh?
I'm getting it.
Better use your scientific arrangement on that. Yep. Alright. So they both work. Now you don't need to store. So 45 to do the same thing. Tan squared 45. Well, hang on. Tan of 45 is 1. So 1 squared, which is 1, plus 1, which is 2. Take away 2, which is 0. And then now try 225, please. So 10 of 225 all squared plus 10 of 225. Take away 2, and you should also get 0. Okay, so very handy thing on your calculator for multiple expression calculation. But, however, when you do an assessment or you do your HSC, alright, you have to hand in your calculator start of your exam and they will clear it. So you can't have set things on your calculator ready for your exam. Alright, they will clear it though at the start of your exam. And I'll be doing that from now on too. So you know what's going on. Alright, so therefore we have 4 possible solutions for that expression. So if we were to graph this graph, okay, so tan squared of theta plus tan of theta, take away 2, which is equal to 0. If we were to graph it, extension 2. Alright, that would be something I would not expect a mathematical extension 1 student to do. I mean, theoretically, you could all do a table of values and you can plot points, but in terms of the accuracy of the graph, it's only limited when you're plotting points. Sort of table of values. Alright, H, last one. And those people who are watching the video, if you need a lesson on how to store things in calculator, please come and see me. Alright, H. So, cos squared theta, which is equal to 2 cos of theta. Kyle, Gavin, last one. Get this done, and then I'll have to get back to maths block about 5 minutes before the bell to help set up for my class test for my junior class to spend the rest of the day. Okay, so how am I going to solve this one? Good. Okay, if anyone was going to tell me you're going to divide both sides by cos, you can't do that because you will eliminate some of your solution. Alright, so cos squared theta, take away 2 cos of theta, which is equal to 0. Cos, so now we're going to factorise, so cos theta, cos of theta, take away 2, which equals 0. So factorise the cos theta out of both those terms. So we have cos of theta, which equals 0. And we also have cos of theta, which is equal to 2. Alright. So to get that basic angle, you need to go shift cos 0 and get that value, or you have to consider your graph. 90. Alright, so considering the graph, cos is a phase shift of your sine curve, and it cuts the x-axis at 0, at those y values 0 at 90 degrees. Alright. Now 2, it's not so straightforward, okay, there's no basic result for that. Alright, so we have the basic angle on the left hand side, which is 90 degrees. And on the right hand side, the basic angle number 2 is going to be cos inverse of 2. So again, we're going to have another go at storing. Alright, once you've stated those angles, basics, you need to then consider your quadrant. So, 0 is that point between what defines all your positive numbers and all your negative numbers. Okay, so when you get a solution of 0, okay, with neither positive or negative, okay, what you need to do is consider all 4 quadrants. Okay, so theta is going to be 0, 180 and 360 degree. Okay, so remember the first quadrant is the angle, second quadrant 180 take away, third quadrant 180 plus. Okay, so you're going to have 180 twice, and then of course you've got your endpoint. Alright, over here. So cos theta equals 2, so where is cos positive?
A and C.
Right, first and fourth. So theta is going to be the basic angle, which is cos inverse of 2, and also 360 take away cos inverse of 2. Alright, so there are 5 solutions there. So the remaining time we have, I want you to check all 5 solutions back into this equation here. Alright, so that we can put it equals 0. Alright, those 3 angles, also storing or either putting into the calculator into that expression. Have another go at storing.
How do you do cos squared?
Sorry?
Do cos squared.
You would put in the calculator open bracket cos of that angle and then square it.
Silly.
Yep.
Silly you, Robin. Silly Robin.
Okay, so remember that notation. So when we want to put it in the calculator, that is what you need to do. Okay? There's no button that has the cos, tan and sine squared, all that sort of stuff in it. Right, to verify that all those solutions work, please. Or tell me what doesn't work. Okay?
The first one.
So 0 is not a solution. Okay, so again, these are like possible points, and they are not solutions. So you have to go through and test all these points when you had a quadratic. Okay, 180. Hang on. No, because, hang on, the basic angle is 90 degrees, so I've done that one wrong. The theta angle in the first quadrant is 90 degrees. In the second quadrant is 180 takeaway, which is also 90, 180 plus, 270 and 360 takeaway. Duh. No one spotted that out.
Goal's not easy.
I wonder if anyone at home spotted that out before I changed it. Right, try 90 and 270.
Now that you've said that, they're going to watch the video. They're going to come to school and say, "Oh, I spotted that."
Let's see if they watch the video first.
I doubt they'll watch the video.
Like, they're gonna have to. First one works.
So they all should work now technically, because you did solve an equation. That's a good thing that we checked our solution. So if you happen to have finished your assessment early, you would test your solution. And if you have said 0, 180 and 360, alright, you'd be wrong. But you had a chance to check it, and you could have a chance to fix it up once you realise your mistake. So yes, I'm human too. I make mistakes as well.
Damn it. I can't store cosine of 2.
Okay.
I can't store that.
Okay, then you need to push cos inverse of 2. Got that?
Yeah.
Shift. Store. Pick the letter. Oh, that's right.
Ooh.
Well, why would we get the error?
Because it's not
Well, cos, in your, looking at your right angle triangle, cos is what ratio?
Oh, something. Adjacent over hypotenuse.
Adjacent over hypotenuse. What is the longest side of your right angle triangle? Hypotenuse. That means the larger number will be on the bottom of that fraction. Therefore, the fraction will be proper.
Improper.
That is an improper fraction for cos. So, by default, these won't work. Because you'll get that math error. Cos is always represented by a proper fraction.
And 90 is 270 work.
Yep. Alright, so therefore theta equals 90 degrees and 270 degrees. Alright, that is why you need to check your points when you have a quadratic. Okay, because once you square something, it turns something negative into something positive, for example. Alright, since 2 is improper, for example, fraction,
Oh, really?
therefore,
Oh, the internet, would you?
cos 90 and 270 only works. Alright, so now that is exercise. The rest of them picked a good time to go away for a couple of lessons. Not a very good couple of lessons to be away for.
Oh, yeah.
They're gonna come back and be like, yeah.
Yep.
They're going to come back in their first maths lesson. I'm just going to hand them each a bottle of bleach.
Alright, so that's it for me today. They could have picked their time with the sine rule or something, because at least they've seen that before.
6 minutes. That 6 minutes needs to hurry up. I really need to pee.
Alright, what do you guys have last?
Hospitality.
Oh no. I'm going home to do biology.
That means Robina's got to study.